This is the video going over the Chapter 7 review packet, the multiple choice section. All right, so for number 1, there is a little bit of a different language they're using than what we used in class. They said in the second sentence, the expected value of D hat is not equal to D. Expected value, another way to say that is just the center of the sampling distribution. It's the sample that kind of gives you what you most expect. It's the thing in the middle. And remember, expected value is a way to talk about the mean of a random variable. And that's what they're saying. It's the mean of that sampling distribution, the center of the sampling distribution. Okay, so they're saying that D hat is not equal to big D. D is the population. So the sampling distribution is not matching the parameter. I drew a picture here where here is about the center of D hat. And, you know, all the different points are different D hats, but maybe over here is your population parameter, your capital D. The problem here is that we're biased. This is a biased estimator of D. So the answer is E. And we don't know anything about the shape of the sampling distribution. They didn't say anything about that. So we can't say anything about normal, binomial, or uniform. Okay, for number 2, a lot of what I did on these problems was they keep giving you all these numbers. And I always try to figure out what is each number, label it with its notation, and then that helps my brain keep track of which equations are we using and what is connecting to what. So we have 100 is N. We said 7% of those contacted made a donation to the charity. So of those contacted, that's in the sample. So 0.07 would be P hat. They said population proportion, those who make a donation when contacted by phone, is known to be P equals 0.05. So they just gave you the population proportion. And we want to know what best interprets the mean of the sampling distribution. Okay, so this is an interpret. This is which wording most closely matches it. So I kind of wrote in these, the ones that are wrong, what went wrong. For A, if they put in the mean of the sample proportions, that would make that correct. Should be an S there. But it's not that the sample proportion is 0.05. It's there's a whole bunch of sample proportions, right? And technically, if anything, the sample proportion is 0.07 because they gave that to us in the problem, if we're going to assume it's a particular sample. But here, the mean is the center of the sampling distribution. Anyway, they need the word mean. For parts B and D, they said 0.07. Those are wrong because they're referring to P hat, not P. C is correct. And then E is just a different thing. They're kind of referring to the whole Z-score, what's the probability of being beyond this thing, and that's just not what's happening here. So the correct answer is C. Okay, in 3, again, I started labeling all the numbers inside the paragraph, what they are. We have 0.325 as our P hat. We have P is 0.325. Okay, actually, they're saying, I should take that back. This is not P hat. That would be P, 0.325, because in the simulation, they were using that 0.325 and saying that we're going to make that our true proportion. Okay, so didn't mean to erase that. There is an issue here with, there's a number of trials and there's also a sample size. So say for simulation A, it's 1,500 trials. That means the sampling distribution, if it were a dot plot, would have 1,500 dots in it. So that talks about how many trials are run, how many samples make up our sampling distribution. That's different than our sample size of 100. So for each of those dots, it's a proportion that is something over 100. So each sample was out of 100. You got a proportion from that. And then a dot went on that particular proportion for that sample. And they repeated that process 1,500 times. Okay, so we do, because both simulations use the same true P, and the center of the sampling distribution should be at matching the population, the centers should be equal. They should both be 0.325. Now, for variability, that comes down to this concept, that a higher sample size makes for a shrunk in sampling distribution, makes for less variability. Because if you have big samples, if you end up with outliers in those samples, there's a lot of other data points to wash out those outliers. If you have little tiny samples, having an outlier in there will still have a pretty big effect. And so you'll end up with outliery samples, kind of extreme samples. Okay, so higher sample size makes for a lower variability. So that means simulation A has a higher sample size. It should have a lower variability. A will be less. Okay, so for number 4, again, I figured out my P and my P hat. This is asking about, well, normality is one of the things. So that's large counts. We had to test out the NP greater than 10 and 1 minus P greater than 10. They're both fine. 69 and 81 are both bigger than 10. So we can say it's approximately normal. And then the mean should match the P, not the P hat. The mean of the sampling distribution should match, the center of that sampling distribution should match the true population. The P hat, the 51, is just one particular proportion inside the sampling distribution. It's not necessarily at the center of that sampling distribution. Okay, so for number 5, for this one, it's just kind of plug and chug with the equations, figuring out what is what. 0.29 is P, so that's what's getting plugged into your calculations, not P hat. And just looking up the right equations. And on a side note, when a problem like this shows up on the test, Canvas won't let me write equations in the answers. So when a problem shows up like this on the test, I will actually figure out what those standard deviations are. I would do the formula and then have the actual answer as one of the possibilities. So expect that on Canvas, you won't see equations. You would see what it actually equals. Okay, so for number 6, there's a lot of numbers in there I had to figure out. And they wanted the mean and the standard deviation. So again, kind of plug and chug. It's figuring out, okay, it's means. So it's these equations and which one goes with female, which one goes with male, and what plugs in where. So, I mean, that's a piece of advice for the test. When you're not sure where to start, figure out all the numbers in the paragraph, label them with what they are. You have to figure out, am I dealing with means or proportions? And am I dealing with one sample or two sample? So you can narrow down which set of equations you're interested in. Okay. For 7, this one, I wrote my work down here. It's large counts again, and you have to test it for each sample for coin A and for coin B. Coin A just barely meets it. You get 10 for both of them. And coin B fails here. So 20 tosses is enough for coin A, but not enough for coin B. Okay, for 8, I'm going to zoom this out a little bit. I like this problem a lot. So you know that P is 0.9. They told you that. So that means your sampling distribution should be centered around P. It should be centered around 0.9. And you also know that you had 50 trials. So there should be 50 dots total. Each dot is one trial. So if you look through, the first 3 graphs don't have enough dots. There's not enough trials happening there. Not enough samples. D and E have 50 dots, but it needs to be centered around 0.9, not 90, but a proportion. Not a count, but a proportion. Oh, back up, 9, not 0.9. Centered around, sorry. Should be centered around 9 because it's 90% of a sample size of 10. 90% of a sample size of 10. So they didn't actually give us an option of doing proportions. There was no 0.9 option, but 9 would just be the count. So this would be frequency or counts. So E is your best answer. Okay, and then for 9 is really just notation, knowing that X bar is a sample mean, so a statistic, and mu is a population mean, so a parameter. And so there is some population mean out there, right? And you get a sample that is trying to estimate what that population mean is. X bar goes with mu. Okay, I think that's it.